Yeah, normally I don't like to follow Peter, but it actually falls into kind of what I'm going to talk about. And I always tease Keith and everybody here that all this stuff we do, none of it matters if you don't have good antenna technology. So I'm going to talk a little bit about the elements. I do want to tell a story about a troubleshooting deal we did with a warehouse. They called us up, network was working great. Yesterday, it's not working great, it's not working great. And we were like, what changed? Oh, nothing changed. We finally, doing it remote, we said, send us pictures. Well, they sent me pictures, and I think it was this antenna, it was like this. I said, oh, what happened? Oh, we didn't notice that. What happened was their forklift driver, it was a distribution center, spun around, hit it, boom. So one thing, Peter, I'd like you to, maybe if you'd add to your slide, is the one that showed the different scenarios, is the antenna. It's important. Even was it 2 nights ago, we were at the restaurant, the access point was put where wasn't in the right polarization. Small restaurant, it was probably okay. But anyway, so it's all about the antennas is my conclusion for you. Anyway, so talk about antenna elements, radomes, and a purposeful design. So obviously, one of the reasons why I give you guys antennas at every one of these deals is, one, I want y'all to test them. Two, I expect you guys to break them apart. I know Keith does, and I know you guys, and Alan, I know you break them apart probably, because you want to be able to see what's inside of them. But one of the things that people always ask us is, okay, what makes you decide to use maybe a printed circuit board design versus what I'd call, if I can bust this dude, metal element. So I want to talk a little bit about why we use both of these and a little bit about the radomes and stay within my timeline. So, well, it helps if I turn the power on. Okay. So that's what I'm going to talk about. So a little bit about the elements. There's really 2 different types of elements. First one, printed circuit board. It's not that. It's actually this. Is what everybody's comfortable with. Standard printed circuit board design works very well with Wi-Fi. I would say it's the most common design we use when we're making antennas, although we do use metal elements. But the reason why we like to use a printed circuit board is a couple main reasons. One, it's really good with dual band technology. A lot of what we've done and a lot of what we do is we try to make our antennas easy, so we have both 2, 4, and 5 gig. In fact, if you guys look at these antenna elements, you can actually see the 2, 4, and the 5 gig as separate elements. Harder on the smaller antennas. Some of our bigger ones, I think last year I brought that 13 dBi, real easy to tell, but it's really good for dual band. Also, when you're using printed circuit board, you can actually do filters if you want to filter certain frequencies. Maybe you have an application that you got to block out something, maybe it's a regulation. Really good with printed circuit board, plus all kinds of antenna shapes. We're working on an antenna right now it's for an outdoor parking lot, and it's a crazy design, but we could only do it if we were using printed circuit board. Really good for wideband, covering like 2, 4, to 2 to 6 gig as an example. Good consistency, simple production once you get it done. Great for high volume. Problem is very expensive initially out of the gate. So we like to build lots of them when we're doing printed circuit board because it can be expensive per unit if you do low quantity. In the gain, it has a little bit of circuit loss versus the metal, which is kind of odd. I guess it's just part of the manufacturing. They say up to 2.5. I've never seen it that high, but sometimes we get about 1 dBi loss. You just have to design the antenna accordingly. And obviously, the application's more around, Wi-Fi and such. Metal antenna elements. Everybody, I think, is familiar with this one. This is the famous antenna that UC tried to carry on in the Heathrow Airport back home and got kicked off the flight. And as you can see, the elements they don't look good, especially in the rear. But they are good. This antenna is actually one of our #1 selling antennas. And people say, why did you not use printed circuit board? When we did the chamber test, we actually did a prototype with printed circuit board, did a prototype with the metal elements. It just worked better. So we're like, it works better. People like it, so we built it. And it is lower cost, specifically for lower volumes. As you get to higher volumes, the printed circuit board gets better. The only problem is, and you can see, and I'll leave these open, you can see the metals, the welding is pretty intricate. And there can be problems if you're mass producing. It's not as consistent as printed circuit board, although we've had a pretty good luck with this guy being very consistent. And the thing is, when you're using the elements, just, if you were actually going to go build your own antenna, which some of you guys probably would try, don't use magnetic material. Make sure you're using something. This actually has aluminum and brass together, which is not uncommon to have, like a little ground plane. Some of the applications, obviously for Wi-Fi, and a lot of the lower bands antennas you'll see from lower frequencies use a lot of metal elements. And then that's why you'll see some of these lower band or lower frequency cellular antennas are all these big metal elements. So looking inside, real quick, if you were to cut open these most common antennas in Wi-Fi, this is a rubber duck. If you've never cut open a rubber duck, do it. It's kind of fun, but it's a big metal element. Omni, I just showed you the metal one. We actually have, this is a 4.6 Omni. That's a 3.4 Omni, but it actually is a printed circuit board. Patch antennas, most of our patches, because of the technology, we use printed circuit board just because it performs better and allows us to do different things. Everybody's familiar with the Yagi antenna. We call it the Fred Flintstone comb. Parabolic dish antennas, and then your sectors. Inside, a lot of these using just standard metal elements. So after we determine what the element is and we say, okay, we really like this performance, then it becomes about the aesthetics. What are we going to put over the antenna to make it pretty? There's actually one option, which is more common in the cellular world, is a naked antenna. You just don't have anything on it. So the only problem is I guess a benefit is there's no attenuation, although these don't add much attenuation. But they're ugly. They can be damaged. And I figured you guys could relate to ugly in that picture. I didn't put that in. That was Amanda's idea. So, whoa, number one. Thank you. Application normally for longer range bridging and Yagi and like grid antenna applications. The most common antenna that we use, or the radome material, is UV stabilized ABS. And UV is critical. If you don't use UV, I don't know if y'all have ever seen antennas that are 3 or 4 years old that are yellow, or I've seen them pink before. Actually, one of our competitors shipped a pink antenna. But we use UV stabilized ABS because it's good weather resistance. It's a very stable plastic, and it's really good for injection molding. So we can make all kinds of shapes in anything you really want. And one of the things is once you get past the expensive tooling costs, the production costs are low. And we try to make them, with a real clean, has a real clean, smooth finish, maybe make it look like a smoke detector or something that is unobtrusive. Because as you guys well know, obviously aesthetics are always important. And the big thing is we always get the question, does it affect the RF performance? No, it's almost negligible. You could test it with or without it, and you really can't tell the difference, which is very important. So that's what I would say is the most common in the industry. So it's good for small, panel, omni, complex shapes and things of that nature. UV stabilized PVC. We don't use it as much. It has a lot of the same pros and cons of ABS, but if you guys come up here, and again, I think you have seen it, it doesn't have the smooth finish. It's real rough, and it makes it where it's just not as easy to design and build a good antenna solution from. So we don't use it that much, but it is out there. And it's used a lot more in the cellular, again, large base station type antennas that you see on the big towers, on top of all these buildings. A lot of it will be UV. Again, it all has to be ultraviolet. One we do still see a lot of, and I actually like, is fiberglass. And fiberglass is very good. And Keith, you remember the old 900 megahertz antennas that were this big? They were all fiberglass. Because if you didn't do anything else, they would snap. So fiberglass is very tough, very rugged. Anything 10, 12, 14 dBi, these big, for like point to multi-point applications, probably are going to be fiberglass. Problem is they don't look very good. Back to the Allen example. And the appearance is rough and it's pretty expensive to do. But it's good for, again, large omni antennas. So in other news, one of the things, and I said it, I purposely put in y'all's bag where y'all can get any of our antennas. I do recommend you call us though, let me tell you why. Every radio manufacturer, I don't know why they like to do it, has different connectors, or it's hard to tell which one's which, or they may have different number of leads, or you may just want to try something different. Let us know. And the good news is, which we didn't have last year, is we have this stuff, even the free demo stuff here in Belgium. So you don't have to ship it across the ocean. You can actually get it here close. And we did that on purpose to make sure that we kept the cost down for you guys. And I'm right on schedule and on time. That's my contact. If you guys, I do want to get everybody's business cards if you don't mind at some point. But anyway, thank you.